Hello, welcome and happy 2024. On today's series, I'm going to talk about working with large data set of tasks. So from the beginning of the series, we have been focusing on how to run code concurrently, and we have been using the task module to achieve this concurrency. However, when leveraging the concurrency, we also need to be more cautious, more so as we scale our product to avoid overloading the system resources. So here is an example of an application sending messages to 1 million users. So what if we try to send the messages to all the 1 million users using the functions that we are aware of? So there's the task async and the task.start. We used these two functions to start a process to start a task concurrently. So I'm going to go to my code editor and see what happens if we try to start this process using the task async and task start by. And let's go to the code editor. So this is still the module that we've been using all through the series. The module is for sending messages, and in here we already defined a function for notifying all users asynchronously. So there's the notify all asynchronously using the task.start. So here we give it the notify all asynchronously takes in a list of numbers, loops, iterates through the numbers, and starts a process for each task of sending a message to the given number. There's also the notify all asynchronously with async. It also takes a list of numbers, it iterates through this list of numbers, and start a process of sending a message to the given number as well. So the async expects the task await or the task yield to be called so that we can be able to retrieve the output. So the task async usually returns a task struct. So to retrieve the output of the output of the task that it was performing, you must use either task await or the task.yield. So here I'm using the task await to achieve that. Okay, so our goal is to see what happens when you try to send messages to 1 million users. So I will start with the notify all asynchronously, which is using the task start. So the first step is to start an interactive shell. So I write the command ix-x mix. Then we need to have ability to access the function in here. So I will go ahead and import this so that I can just call the functions directly. Okay, so there we go. So the task that the task that will be running is the task send message. It takes in a number. We have added a delay for 3 seconds. Then after 3 seconds, it will report the message to the given number and return an OK received status. So let's call the notify all asynchronously. And we'll give it a list of numbers. So I'll give it in form of ranges because you can't write 1 to 1 million numbers in a list. So I'll give it a range 1 to 1 million. Okay, and we are ready. So I'll just close it first quickly because I want to demonstrate something. So the first thing that we are getting is an error message. Too many processes. Yeah, because when we iterate through this list of numbers, we are starting a million processes that will be responsible for performing this task of sending a message. Then we have the system limit error. A system limit has been reached, so that is what we've been told. There is a limit on how many processes can be concurrently started in the beam, and the default value is 262,144 processes. So that is the limit. I'm not certain if this has changed, but we can look at it again. So I'll start my interactive shell again and import. Okay, so now let's call the notify all asynchronously and give it the range 1 to a million. There we go. So I'll let it run this time. So you can see it's sending messages to the numbers, but let's see if there will be a limit here or how many messages will be left out. Okay, so I'll give this time to run. So we have already reached 200 and okay. So from here, I can see that we have already reached 261,000, and the highest number I'm seeing is 261,898 and 98. So this means that these are the numbers of messages that have been sent out, and we have like almost, if we subtract this with a million, let's see like how many numbers have been left out. Okay, so let's see how many numbers have been left out. So just subtracting here. So 738,102 numbers have been left out. So if this was a production application, that means there will be users who are receiving the message and some are left out. If it's an important message, that it means most of the users will be left out and not be notified. Okay, so this is almost a number. The number here, the number of the messages being sent out, the highest, the maximum is almost uh, nearing the default value that I had said earlier, so that is 262,144. So I'm not sure if this value depends with the machine. Okay, so this was the task start. Let's see what kind of behavior we get when using the task async. So I'll go ahead and call notify all. with a sync function. And give it the same range. Sorry. This is coordinate with the def keywords. I'll just remove that. Okay. So a sync process has been started and it has started sending the messages. So the difference between this and the task start is that we're not receiving we're not told about the system limit error. But let's see what happens. So I'll just let it run. Now we have reached 500,000. Now it's 600,000. So we literally sent the 1 million messages. Do you expect the tasker sync to do that? 800,000 messages being sent out. We have reached 900. So I'll say all the messages have been sent out. Let's see if we can do something here. Okay. Okay, so with the task async, all the messages have been sent out. But remember, we are starting a million processes, and this can put sudden pressure on your system and even cause the service to be unresponsive. So here we have been, okay, so what is the advantage of notifying all users asynchronously? So the first one is definitely we have leveraged concurrency, and also the tasks are isolated, and in case one task fails, the other task will continue running. But there's a disadvantage of starting 1 million processes, and this is so there's the disadvantage of starting a million processes is that we can end up overloading our system resources because all the million processes will put sudden pressure, and this pressure can also cause your system to be unresponsive. So what's the best way of handling such a situation? So in our next series, we shall see how we can manage a large data set of tasks while using the task model. Thank you, and welcome to the next series.